Hey again, everybody. I'm going to go ahead and work through some trigonometric ratio examples where you have to solve for missing sides. This is more applying the actual ratios than just setting them up. So let's go ahead and start with a right triangle. Let's do something a little different. Let's go, I don't know, let's go this way. Let's get real wild and crazy. Let's have our right angle over here. Let's go ahead and pick an angle measurement that we can use. Remember, this doesn't have to be anything special. But it does kind of, it almost looks like I drew an isosceles by accident. But let's just say instead of 45, let's go 40 degrees. Okay, so it looks like it could have been isosceles, but it's not. And that'll be A, B, and C. Let's call this side little a, because we don't know that one yet. Let's call this one little b, because we don't know that one yet. And let's just go ahead and say this one is 10, just for the heck of it. So the question will most likely be, please solve for A. Please solve for B using the trigonometric ratios. And this is the moment where you say, all right, how do I know which one to use? Okay, some of you, you gotten used to, maybe just tangent because we did so many of those. But as you can see here, if you tried to use tangent, you'd get your opposite over adjacent, and those are two things we don't know. So first thing I'm going to do, like I always recommend, is to label my picture. This is the angle I choose to use because it's already in the picture. It's already there. I could figure this one out and use it. It doesn't actually matter, whatever your preference is. I'm just going to use the one that's already there because I don't really care. That means this has to be my opposite side. This has to be my adjacent side, right? Opposite is across, adjacent next to the legs. And then, of course, the hypotenuse is the one across from the right angle. So this is what you ask yourself. What piece do I need? What piece do I have? I need the opposite. I also need the adjacent, and I have the hypotenuse. So because I have the hypotenuse, I want to make sure I use that in my equation. Okay, so whatever trigonometric ratio I pick, I'm going to pick the one that uses hypotenuse because that's the number I actually know. And as far as going for the A and the B, well, I'll just have to do one at a time. All right, now how do you remember which trigonometric ratio goes with which actual, setup? So a trick we talked about in class was the ancient, Native American Chief Sohcaytoa, who discovered the trigonometric ratios hundreds of years ago. And because of his discovery, we decided to name all these ratios after him. So the letters in his name actually stand for all the trigonometric ratios that we've learned. For instance, S stands for sine. O and H go with opposite over hypotenuse because that's the sine ratio. Opposite over hypotenuse. That takes care of sine. The C, of course, stands for cosine. Now that you start to see the pattern here. A, of course, is adjacent. And H, of course, is hypotenuse. So the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And then, of course, the last one has got to be tangent, which is opposite over adjacent. All right, so now this will help us remember which one goes with which. So I'm looking at this. I'm going to go ahead and say I want to solve for A first. A is the opposite. So I need the opposite. I have the hypotenuse. Which trig ratio uses opposite with hypotenuse? Well, that's definitely the sine ratio. Sine is opposite over hypotenuse. Okay? So the sine of the 40 degrees must equal the leg opposite, which is A, divided by the hypotenuse, which is 10. And if you did any of the tangent stuff that we learned last week, then this should be really, really easy to solve. It's just we're using a different ratio instead. Okay? So at this moment, I'm actually going to go ahead and get the sine of 40 degrees. So 40, I'm going to hit the sine button instead of the tangent button. Right? And then I get 0.6428 equals A over 10. Now, depending on how your comfort level with your algebra, there are other ways you could solve this maybe a little quicker, but I'm just going to show every step for the people that are still having trouble. For instance, right here, some of you are like, oh, can't I just multiply, or maybe can't I just divide? And you might be right, but I don't want to. I want to make sure everybody understands what to do. And I think the safest thing you could do would be to put this over 1 and cross multiply. then you'll never make the mistake of guessing, do I multiply, do I divide? Okay, so yes, it does look like the 10 is going to be multiplied by the, the sine of 40 degrees. But in case you didn't see that, you do it this way and you'll never make that mistake. So a times 1 equals 10 times, the sine of 40 degrees, which was 0.6428. So that means a must equal, if I multiply this by 10, I'm going to get 6.428. And there's your a value. Okay? Again, this is not a necessary step, but I'm recommending it. If you're watching this video, it means you're probably asking for a little bit of help. This is a good strategy for you. If you're watching this video just to reinforce what you already know, you probably could have looked at this and known immediately to just multiply by 10 and you would have been all set. Okay, but I just want to make sure everybody gets it. Okay, that takes care of A. Well, now I sort of need to start over a little bit and go with B. Now, the good thing is the way I labeled it is still correct. Okay, B is still adjacent. I'm not switching angles. I'm just switching what I'm trying to solve for. So now I need the adjacent, and I have the hypotenuse. And if you're saying, but Mr. Miller, didn't we just get the opposite? Don't we know the opposite now? Yeah, technically we do, assuming we didn't make a careless mistake. But I'm going to play it safe and use the number that they gave me in case I did mess that up. Okay? Now, it would work if you used A, but like I said, I'm going to play it safe. And maybe you chose to solve for B first. If you chose to solve for B first, you would have had to do it this way anyway. So if we're solving for B, we have we need the adjacent and we have the hypotenuse. So we need to look at our trig ratios and determine which one uses adjacent with hypotenuse. And that's the cosine. The cosine is the adjacent over hypotenuse, and now we can set that up. So cosine of 40 degrees equals adjacent, which is B, over the hypotenuse, which is 10. Okay, and obviously if you see the pattern that happened here, you probably can figure out what to do here. But again, let's play it safe. Let's pretend that you're not sure how to do the algebra part. So let's just get the cosine 40 out of the way and go from there. So cosine 40, cosine is 0.7660 equals B over 10. I'm going to put this over 1 and cross multiply so I don't make any careless errors. So B equals 10 times 0.7660. Multiply by 10, that's not too bad. And this is going to be 7.66, and then technically 0, but it's fine, just 7.66. And there's your A and your B. And something fun you could do, because it's just so much fun. I'm sure on Saturday morning at 8:48 a.m. this is what you're working on. But if you just want to have a little fun with it, you could check your answers. If you know all three sides of a right triangle, they should have a very special relationship. And we did this a lot. If you have a right triangle, well then this leg squared plus this leg squared should equal this hypotenuse squared. So let's check it, just for fun. Let's do A squared plus B squared and see if it's equal to the hypotenuse squared. Okay, oops, yeah, I'll cut off there. This is A squared, B squared, and C squared. Let's see if it actually worked. Alright, A squared, 6.428 squared. That's 41.3192. And then now 7.66 squared, 58.676. And I'll put a question mark because I don't know, is that equal to 100? Well, 41.3192, oops, 41.3192 plus 58.676 is 99.952. Uh-oh, I must have made a mistake, huh? No, of course not. We obviously rounded all these answers, right? Sine of 40 wasn't exactly 6428, 7.660. It kept going. And then even when I got to here, when I squared it, I had to round it a little bit. So this at least tells me I must have done it right. Okay, if you want to be really sure, I suppose you could go back and write down all the decimals all the way down and try it again. Okay, but that's what happens when you round things. Alright, this is pretty much what you need to be able to do. So hopefully this helped. Please let me know if you have any questions, and have a good weekend, okay? See ya.